Okay, so this is going to be finding the volume of known cross sections. So we got started with this on Friday with Play-Doh. We're going to finish it up today. And if you can remember all those little areas we found on Friday, is definitely going to help you. If not, we can kind of go through the process again if you need to. So let's just start off and draw a couple of functions that are intersecting. All right, and let's say this first intersection is at the point AB, and the second one is at CD. All right, and then we have this little shaded region that we're going to fill with cross sections that could be semicircles or right triangles or equilateral triangles or rectangles or squares, lots of different options. So the first thing that we're going to do is draw a sample cross section. And I'm going to color code my notes again today. You guys can or not, it doesn't matter to me. But sometimes your cross sections are perpendicular to the x-axis. So I'm going to do all of those in green. And then sometimes your cross sections are perpendicular to the y-axis. So I'm going to do all those in blue. All right. So I'm just going to do a few sample cross sections for each different type of um, base. A couple or a few that are vertical and a few that are horizontal bases. Okay, so we're just going to have a semicircle, an equilateral triangle ish, and a rectangle. And then our next step is to write an expression for the area of one cross section. Right. And so if your base of your cross section is a vertical base, you're going to write that area in terms of x. And then if your cross section has a horizontal base, we're going to write that in terms of y. So we've been doing that all along with all these volume and even the area between two curves. So that's nothing different than what we have been doing. And then the last step is to set up the integral. Right. And the way these will be worded, they'll either be perpendicular to the x-axis or perpendicular to the y-axis. So, whoops, I'm going to do this in green. Perpendicular to the x. The volume is going to be the integral. And then what do you think your upper and lower limits are going to be? if it's a perpendicular one. And we're looking at A, B, and C, D. Would they be X's or would they be Y's? They would be X's. So it's going to be A to C of whatever that area is for one cross section. You fill in that area for all the cross sections when you do the integral. And then we'll have perpendicular to the y-axis. The volume is going to be the integral. And in this case, we're going to fill in all of these from bottom to top. So it's going to be from B to C of A of Y D. Oh, sorry, B to D. A to Y dy. A of Y dy. Okay. So on these examples, I have just two functions, and then we're going to do several questions out of the same two functions. And then your assignment is to set up the same way. So these are our two functions, y equals x squared minus 1 and y equals x plus 1. R is the region bounded. So I'm just going to go ahead and shade that region. And it's a good idea to figure out where these intersection points are. Sometimes it is what it seems like it is. Like, for example, down here, this is definitely -1, 0. You can tell it crosses exactly there. The other one, it may or may not be 2, 3. I know you guys did some in the activity where it looked like it was like 1, 2, but it was actually a little bit off. So it is actually 2, 3 here. If I plug in 2, I am going to get 3. And then if I plug in 2 here, I'm also going to get 3. So it is 2, 3 in this case. Okay, so number 1, region R is the base of the solid. Each cross-section perpendicular to the x-axis is a square. So perpendicular to the x-axis would be, wiggling, this one. And we have a square this time, so I'm just going to draw one cross-section. So to find the area of a square, you just square a side. So what is that green side? How can I represent that green side everywhere on that region? Right. So it's top minus bottom, just like we have been doing with all the radii that we did. It was either top minus bottom or right minus left. Same thing here. So that green line is top minus bottom. Top is the line. So x plus 1 minus the bottom is the curve, x squared minus 1. Now, it's up to you. You can actually subtract that if you want to, but if this is a calculator question, I wouldn't. You could make a mistake there. I think it's going to be easier if we just leave it like that, especially if it's a calculator question. Now, if it was non-calculator, you would need to subtract it and simplify, but we're going to use the calculator on these. So to represent the area of one of those squares is going to be the side squared. So our side in this case is x plus 1 minus the quantity x squared minus 1, and then we have to square the whole thing. All right, so our integral for our volume, what are going to be our lower and upper limits? It's going to be the x's, so -1 to 2 of that thing we just wrote for the area. All right. Now, this is one that we could do without a calculator. It would be very tedious because you'd have to square a trinomial. But we're just going to let the calculator do it because I don't want to spend the whole class period doing tedious things. If you type it in, you get 8.1. Right, let's look at the next one. We have the same region. Each cross section perpendicular to the x-axis is a semicircle with a diameter in the region R. So this green line is going to be our diameter of our semicircle. Now this area is a little more difficult. Does anybody remember it from doing the Play-Doh? It's pi over something. That's okay if you don't. We can do it real quick. So a semicircle is 1/2 pi r squared. So 1/2 pi. What is r in this case? Oh, sorry. Our diameter I didn't write. Same diameter as the base last time. So what would the radius be? Half of that. And then we would square it. So I'm definitely going to have the same thing like last time, x plus 1 minus x squared minus 1 squared. But what would be in the front? Mm-mm. Mm-mm. Yes. You have to square this. So it's pi over 8. So if you can remember that, pi over 8 for all the semicircle cross sections, that'll save you some time. If not, you can get there. All right. So our volume is going to be or I'm going to go ahead and stick in the pi over 8. That's the way I like to do it. And then we're going to go same upper and lower limits, -1 to 2. All right. And then that's going to give you 3.181. Right. Then the last one, and well, actually, we have two more. So this time we still have that same base of our region. Each cross section is still perpendicular to the x-axis. But this time we have an equilateral triangle. So that base still is the same thing, top minus the bottom. All right, what do we do here? It's 1/2 base times height. I know my base is that same thing. What's the height? It is not the same. It's the square root of 3. So we'll say this is something, this would be 2 times that something, and this would be the square root of 3 times that something. So 1/2. My base is definitely x plus 1 minus x squared minus 1. What is that? What is this little dot line? This side. It's the equilateral triangle. What? Half of that. So it's the square root of 3 times half of that. All right, so if I multiply all these little numbers in the front, what is that going to give me in the front from in that area? Square root of 3 over 4. And then you're multiplying this by itself, so it's squared. Now, if just like semicircle, if you can remember when you're doing equilateral triangles, the square root of 3 over 4 in the front, that can definitely save you some time. So maybe you might remember that from the Play-Doh. I don't know. That's why we did it. This one says to set it up, but don't evaluate it. So we're just going to set it up. Okay. And we're going to do one more on the back. It is perpendicular to the y-axis, and we are changing the base a little bit. So it's still bounded by those two functions, but it's also bounded by the x-axis. So the actual region we're talking about is this region. But these are still -1, 0, and 2, 3. But this time we're perpendicular to the y-axis. And this is the first time we've talked about rectangles. The rectangles are actually way easier, but it confused some people last period. So each cross section perpendicular to the y-axis is a rectangle with a height of 4. So before I worry about what that base is, I already know the height is 4 on every rectangle that we're doing. Now, because this base is a horizontal base, what are we going to have to do to our function? Right, we need to put them in terms of y, which means solve for x. And they're not hard to solve for x. We're just going to add 1 and do a square root and subtract 1. Okay. So what's my base going to be? Left minus right or right minus left? Right minus left. So right is the square root 1. Left is the line. So area is base times height. So 4 times the square root of y plus 1 minus y minus 1. Do I square anything on this one? No. That area is just base times height. I don't multiply anything by itself, so nothing is being squared. So my volume, I'm going to put that 4 out in the front. What am I going to go from? Yes. Oops. Now, I want to show you guys something else. The reason why this is cut off is because it makes it harder. If we did that whole region, what would be my right and left? Right is still the same, right? The square root of y plus 1. But what would be the left? Definitely not the line. What do you think? The right was the positive. The left would be the negative. So if we did that whole region, we would add on another integral. We would still have the 4. What would it go from? -1 to 0. And then it's going to be right minus left. Right. So that was doable. We didn't have to do it the other way, but. Okay. So your assignment is these bottom questions. So it's one region that I'm just having you do 6 different ways. But before you do that, I do want you to join the Calcmatic review. So I don't know how difficult it is to do on your phone. You can grab an Chromebook if you want to, but there is the link that you use on AP or not AP Classroom, on Google Classroom, and then I'm also going to give you, starting 30 days from the test, which was yesterday, I'm going to give you a tip of the day, and I'm also going to put it on there for you, so if you want to go back and look at them before you all take the test.